Welcome everyone to a new webinar on resource-oriented sanitation. This webinar series is co-organized by the International Water Association and Eawag, the Swiss Federal Institute of Aquatic Science and Technology. We already had 4 presentations, that's number 5, and this time we focus on resource-oriented sanitation in the United States. And I'm happy to have 3 presenters today. So we will focus on water and also on urine, resource-oriented sanitation. The first presenter, that's Dr. Miriam Hacker. She serves as a research program manager at the Water Research Foundation, building bridges between research and practice. She oversees the utility management and workforce research areas at the foundation and is currently involved with research projects focused on water reuse and decentralization. So there's a strong focus on water. Then we have 2 more speakers. The first one is Kim Nace. Kim Nace was the co-founder and executive director of the Rich Earth Institute in Brattleboro, Vermont. She's currently the CEO of the spin-off company Brightwater Tools. The team of Brightwater Tools is creating innovative technologies to facilitate nutrient recovery for resource-oriented sanitation. And we have Julia Cavicchi. She is the education director at the Rich Earth Institute. She coordinates their Urine My Garden education program. This is actually for home gardeners. Then she's also coordinating the annual Rich Earth Summit, local urine donor engagement, and she supports for other communities adopting pea cycling practices. So I'm actually really happy that we have 3 presenters today. So the presentation will go a little bit longer, but we'll still have enough time in the end for questions and discussions. So thank you again for everyone joining, and I hand it over to the 3 speakers.
Thank you, Kai. Thanks, everyone. And we're really looking forward to being able to talk a little bit more about what's happening in the U.S. The way that we'd like to structure the talk this morning for East Coast, it's 8 a.m., day for the rest of the folks on the call. But we wanted to take first a look at a national level of how resource-oriented sanitation is taking up different research projects, and then doing a deep dive into some of the work that one of the specific actors, the Rich Earth Institute and Brightwater Tools, are doing. So follow with us today. My name's Miriam Hacker. I'm with the Water Research Foundation. And let's see here. There we go. I jumped ahead a little bit, but what we really want to target, especially along the same lines of this webinar series, is looking at general applications in the US, a few key research projects, some different actors that are involved in this work, and then doing a deep dive into some case studies and some specific examples on the ground. So just to start off with, I'm sure most folks know the Water Research Foundation, but I am obligated to make sure that folks understand the purpose and the work that we do. And so we are a collaborative research and innovation organization that operates on 6 different continents, and we serve about 1,200 subscribers. The majority of them are utilities. And I think one thing that we prioritize is connecting practice with research. How do we connect, do a little bit of matchmaking between folks that are able to investigate challenges that people are facing in their day-to-day roles? And so with that, we have 5 different areas that we typically cover. And the reason why I dive into this isn't necessarily a pitch for the foundation itself, but more so, there's a shift in thinking about how research is done in the US, specifically taking a one water approach. And I think that's also really applicable to the conversation today as we're looking at resource-oriented sanitation. So the 5 major categories that we typically organize our research in are efficient resource use and recovery, treatment optimization, intensification, resilient infrastructure, utility operations and management, healthy communities and environment. And I would say when we look at these topics around resource-oriented sanitation, they touch on all 5 of these spaces. There's something to be gained from this work. And so I think sometimes in conversations we have with folks, there's a tendency to want to silo or move to certain parts of the conversation. But the reality is when we're looking at how we're treating our waste and our wastewater, it can cover both efficiency and recovery, but also understanding how do we create more resilient systems? How do we create workforce that can operate and maintain these systems? And then also, how does it protect human health and environmental health? So across these 5 different areas, the foundation has funded about $100 million worth of research for over 20 years. And you might be a little confused if you're looking into the US. I think this is helpful for folks outside the US. The Water Research Foundation is a conglomeration of multiple agencies that formed together in 2017-18. So if you're looking at different white papers or resources, you might find something that's WERF or the Water Reuse Research Foundation. Those things actually joined forces a few years ago. And so when you're looking at some of the efforts that take place in the research space, they're collaborative, they're together, and they're in unison. Folks want to leverage resources rather than acting in silos. So as we were talking, Kim and Julia and I were thinking about, okay, how do we synthesize what's happening in the United States right now in terms of resource-oriented sanitation? And what we realized was the US is very complex. There's a lot of different potential applications, and it would be a disservice for us to simplify it or reduce it to, well, it happens here and here. What we wanted to try and take a look at is what are the different scales where resource-oriented sanitation could be optimal. And that's generally how things are considered for water reuse as well. Similar conversations are happening there too. And so we wanted to first take a look at centralized setup. So for infrastructure that is networked and is centralized, it's collected and then sent to a treatment facility, what we're finding is that folks want to recover resources from those collection systems. What we've seen in a trend in utilities in the US is they're actually transitioning from treatment plants to resource recovery facilities. So I think culturally speaking, there's a shift happening in how we're thinking about our infrastructure. There's also opportunities to really affect the nutrient limits. So in the US, there's strict requirements on discharge from treatment plants and how it impacts environmental health. I know Kim and Julie will go a little bit more into detail later, but centralized facilities are positioned to consider resource-oriented sanitation, given the need to reduce pollutants and to meet those discharge requirements. At a distributed level, that's looking at either a cluster or communities of systems. It could either be treatment or it could be management. So if you've got folks that are managing a group of systems, but it's not necessarily technically a centralized setup, there could be advantages to having resource-oriented sanitation through economies of scale. And we'll go into that a little bit further, but in some cases, for the amount of cost and for the energy that's required and the transportation of what's recovered and the fertilizers that are produced and conveying it, in some cases, looking at a distributed system, there's enough folks there they are able to collect enough that makes it worth your while. And then finally, in the US, there's on-site resource-oriented sanitation, and that's looking at a building scale or at the individual household level. It can range. So for example, in San Francisco, you've got commercial buildings over 100,000 square feet. Apologies, not metric scale, but over 100,000 square feet, you've got wastewater that's being recycled on site. But we're also talking about in other places like Austin, Texas, where folks are recycling water at a household level and using it for on-site irrigation and landscaping. And so some examples that came to mind with resource-oriented sanitation, for example, the national parks recently picked up composting toilets because they had folks that were irresponsibly discharging waste on trails and park sites. And there wanted to be a sustainable solution to how to help folks continue enjoying the park system, but in a way that didn't require extensive maintenance and couldn't be connected to a centralized system. Also, a very niche application, which I personally am just very interested in, is tiny homes. So there's a number of folks in the US that are purchasing homes that under a certain square footage. And how do they access sanitation? In some cases, and this is actually pretty pop culture now, is folks are recommending to folks do composting toilets in their facilities and how to incorporate them. So there's a sub-market for that in the space. But there's also opportunities for building scale applications as well. And we'll have a couple examples we talk about. So a few of the drivers, I mentioned a couple of them, but right now in the US, we're looking at first reducing the drinkable or potable water reuse. So there's water that's being flushed that's at a drinkable level, why are we treating it to that level? Can we reduce the consumption amount, or can we be more efficient with how we're utilizing our resources? The second Ari previously mentioned was nutrient pollution prevention. And then also thinking about how do we connect folks and make sure folks have access to sanitation systems where you might not have access currently, or it's too expensive to connect to an existing distribution network or a sanitation network, or those systems are overburdened. In the US, we have issues with aging infrastructure, not enough funding to be able to replace or do necessary maintenance to systems. And so as people are continuing to develop or thinking about improving conditions, considering how it's impacting the whole is something that's considered. And there's a few barriers. So for example, with some of these resource-oriented sanitation systems, trying to make sure that there's expertise for operation and maintenance. And not to say that expertise doesn't exist, but more so the certification process. This is something that we're finding with water reuse in general as well. So for example, each state has its own requirements. And even though there's a national level certification for operators, it might change state to state on how it's implemented. And for example, what I always tell folks is in the US, we've tried really hard to keep drinking water and wastewater really separate. And now with this emergence of reuse or thinking about, for example, nutrient recovery, suddenly we're bringing those two spaces back together. And in the same way, we've got folks that are working and that are operators who have certification for one sector or the other, either water or wastewater. And now we're trying to figure out a way to combine forces with making sure that folks have the right certification, but it's also not cumbersome. And achieving economies of scale. So what is the optimal scale that allows folks to be able to recover the most from a system and also be able to absorb the costs necessary for transporting treatment and for the operation and maintenance? And then user experience. Something that we've found in a few case studies around the US is perception issues of if something goes wrong, are people flexible with being able to go through that lessons learned? How are we optimizing the vehicle through which this is taking place? And then regulations. Something that we're noticing in the US is that regulations have been created primarily for centralized networks. And this is something that we're finding for both water reuse as well as resource-oriented sanitation. In some places, people are having to follow regulations that were designed for an entire wastewater treatment facility when they're trying to recycle water on site. And it makes it extremely cumbersome. One example is for some buildings in California, they're having to do daily testing, which is extremely expensive at a certified laboratory to determine that their treatment system is able to maintain the certain quality that it says it can. And there's been some changes. In recent years, there's been some work done with National Blue Ribbon Commission for on-site water reuse. And I foresee people getting creative with trying to find workarounds or being able to build out more space and capacity for alternative water systems. And additionally, cost. I think that's pretty self-explanatory. It takes a lot. And something that came up in one of our research studies is there's funding mechanisms built into US policy that allow subsidies or support for developing projects. And in some cases, alternative water systems don't always apply or are eligible for those funding opportunities. And so it's not just the capital costs of installing a system and maintaining it, but also think, how do you legitimize or continue to get people to assume and incorporate the consideration of alternative systems? And finally, space. So, I mean, in a lot of spots in the US, it takes space to be able to maintain systems, to be able to install them. And so making sure that you have the necessary requirements. Now, this isn't as applicable to rural spaces because there might be a little bit more to pull from. But if you're thinking about urban applications, it is definitely something that's come up as a barrier. So I would say that's not necessarily a barrier, but depends on the context. So a couple examples I'd like to go into. And one thing that I always start off with is, you know, when you're talking about a transition to a new technology system, you will inevitably learn a lesson. It is inevitable that there might be a misstep or something that you learn from, and it's not necessarily a setback unless you allow it to completely destabilize the process. Those things are inevitable. And so what we found in the US, there's a couple notable applications, one being the Bullitt Center. And just quickly, I'll go through. Their motivation was to reduce their water use. This is in Seattle, Washington. They wanted to reduce the water use, reduce the nutrients going to the environment, reduce their energy use, aerosols being used in the bathroom, which is really relevant with the COVID pandemic that currently or recently happened, and then also the burden on the centralized system. Now in 2021, they had a composting toilet system, and they also had a negative pressure system that pulled the waste down into the composting toilets. In 2021, they actually decommissioned these composting toilets, and they put out a white paper, which I'll put into the chat, which talked about some lessons learned. So it wasn't necessarily a failure so much as, hey, we had ambitious goals, and now that we did it, we learned quite a bit. And what we'll see is it was actually applied to another system. So something they learned was they needed more space for accessing the composters, and they wanted to be able to more evenly distribute how the waste was going into those composting systems and balancing the load. One thing that they noticed was, because it was such a small system, it was one building, they were actually using more carbon emissions to transport to the fertilizer facility. And also the workforce. There was a huge turnover in workforce, and making sure that everyone was certified or able to maintain the systems was a challenge. And the system resilience, when they had to do maintenance on the composters, they would stop that negative pressure, which meant that some of the odors and the fumes would go up through the building, which is unpleasant for the building folks that were in there. And then finally, the foam flush toilets were causing some challenges with perception, but also with maintenance. So all this to say, there's other examples, and it's actually very interesting because in Portland, just down the way from Seattle, Washington, is the PAE building, which is a similar design. It's a commercial building that was put towards very specific standards for sustainability. One thing that's noticed is that if you look and compare side by side, they have a composting toilet, but in contrast to the Bullitt Center, they improved it by following some of the recommendations. I'm not sure if they're directly connected, but they started more evenly distributing the waste that was going between the composters. They built in more space. They also were separating the gray water into its own storage to be able to be treated for on-site reuse through toilet flushing and non-potable purposes. But all that to say is, this is an iteration. This is a process that you transition from, where you learn something, apply it to another situation, learn something, apply it to a situation until we find the optimal fit. Now, one quick note on funding. That is a very critical issue. Federal funding is primarily available for research. What we found is, looking at these systems, there's usually influxes of funding that happen federally for typically decentralized systems, which is where resource-oriented sanitation can apply. But it's not as common to have designated funding for these types of projects. And so what that's requiring is some creativity with trying to identify either private funding sources or being able to take advantage of those waves of funding that come in at a federal level, and being able to find what the topics of priority are and how they apply to resource-oriented sanitation. So for example, right now, there's a huge emphasis in the US on environmental justice and access to equitable water solutions. And what that looks like is resource-oriented sanitation is a potential avenue for that, to accomplish that. And so rather than looking for specific funding for resource-oriented sanitation, it's trying to take advantage or opportunities to see how it integrates into some of these other priorities that people are identifying. What we really need, though, is a policy playbook. We need to understand what are the different avenues for funding and how can we create a more supportive environment for it. So last thing I'll say, there's a couple things I'll say on this, but one example of the rare waves of funding was back in the 2000s, and it was focused on decentralized water resource collaboratives. It wasn't just on sanitation, though. It was stormwater, it was on water resources, it was on water treatment at a decentralized scale. And it was through a number of national entities that were funding some of this research. I won't go into too much detail, but I want to put this out here as just, when people do it, they do get together. And some of the work that the Water Research Foundation has done has focused on life cycle assessment and being able to understand how can urine diversion benefit treatment plants in the US. And so there was a life cycle assessment done in 3 different case studies with different motivations. One was strict effluent requirements. Another was a little bit typical requirements for effluent, but also larger populations. And what they found was that the urine diversion actually was most positioned to decrease environmental impacts. It also helped with the treatment systems at the wastewater treatment plants. And it was able to offset the need for synthetic fertilizer, which I think was a really major finding from that study. So that being said, I want to pass it over to our friends over at the Rich Earth Institute and at Brightwater Tools. But before we do, we know that the 3 of us aren't the only ones in this space. In fact, there's a number of initiatives going on around the country, and we want to list these here so you can kind of see the names and be able to reach out to folks on your own time, or be able to reach out for a connection. But that being said, I'll pass it over to Julia.
Great. Thanks, Miriam. Yeah, so many of these are different organizations that Rich Earth is partnering with or learning from, and some of them have not historically had circular sanitation as like a core part of their mission, but are more recently integrating it. Others are kind of providing services in this space. So it's kind of a patchwork of different groups all working on different components and trying to learn together. So on the next slide, I'll just kind of introduce Rich Earth to you for those who don't know. We're based here in Brattleboro, Vermont, and Kim and Abe founded the Institute a little over a decade ago, back in 2012. And our kind of main program is this urine nutrient reclamation program that we operate, that is kind of our demonstration program that serves as a platform for both our research that we do, which is including technical research, agricultural research, and social research, and also education, both in our community and region and to other communities across the country. And it's the first and largest community scale kind of urine recycling program of its kind in the US, and something that we're actively working to support other communities in replicating or adopting or adapting to their different contexts. So since 2012, our program has resulted in about 2.3 million gallons of clean water conserved via avoided toilet flushes. And we're now collecting at a scale of about 12,000 gallons of urine every year that we're able to divert and supply to local farmers. On the next slide, we have just kind of a very brief snapshot of what our program entails. We have a wide range of means of collecting our liquid gold. Kind of the main and earliest mode of collecting the urine is through these portable urine collectors on the left here, which we colloquially call the Cubian funnel device. And it's basically a 2.5 or 5 gallon jug with a watertight funnel that we have some plumbing part adaptations that connect it. So we supply those to urine donors and they bring them to a centralized urine depot. We now have 2 urine depots in 2 towns about 20 minutes apart from each other. And so those have vacuum pump stations with a self-serve pump, and then we bring those back to our research center for processing. We also recently have begun doing more permanent installations in people's homes. So we install urine diverting toilets for private homes and urine collecting urinals for public facilities, such as this urinal in a local brewery, the Hermit Thrush Brewery, which we're very excited about. And then we just come out with our pump truck and pump out the nutrients from the homes a few times a year and bring that back to our facility. And then we also have urine diverting and compost portable toilets that we have out in the community as another means for collecting our nutrients. And then we have several local farm partners we work with throughout the years. Our longest term farmer partners have been for applying urine to hayfields. And lately, we've also been doing a number of different agricultural research projects with farmers growing other crops, including cut flowers, hemp, sweet corn, and this year we're trialing urine on some nursery trees as well. So agricultural research and working with farmers to explore how urine can be used for different contexts is a big part of what we do also. Next slide. And I'll pass it to Kim to kind of introduce Brightwater Tools and what they're working on as well. Kim, you're muted.
Okay, thanks, Julia. Hi, I'm Kim, and I'm running Brightwater Tools at this point. We're the spinoff of Rich Earth Institute, and what you see on your screen now is a schematic of our building scale system. This is what we are working towards with various technologies. Our technologies are all in blue or surrounded by the red circles. So we're working on an acidification unit that would help waterless urinals stay or come back to the market more, because the acidification can help with mineralization in the pipes. It can prevent that, or even clean up arenas or pipe systems that have already got scale in it. So we're looking at that. We're also our main core treatment technology that is a kind of unique, I think, to all the other presentations we've seen so far, is our freeze concentrator. We're using this this method to take the water back out of urine, because that will definitely increase that ability for to reduce storage needs and increase the distance fertilizer can be transported for that life cycle assessment. We already have a pasteurizer, which you can see down at the bottom there. Is we do pasteurize the urine as is required by our permits in Vermont, and we pasteurize it for our local use to create what's called a Class A certified fertilizer product. It's EQ, Class A, exceptional quality fertilizer. So that's what we're doing at Brightwater. We have a team. We have charcoal filtration as a final step to remove micropollutants from our product. And we're still very much in the R&D phase. Only our pasteurizer at this point is on the market and ready for other people to purchase. We can go to the next slide, Miriam. So some of the drivers in the U.S. are overburdened wastewater treatment systems. As we do our research, it's kind of amazing to realize that 81% of our wastewater treatment systems, or our resource recovery systems, as we want to call them, are at design capacity, and we have 15% of them that are already at or exceeding that threshold. So there's a real strong need for our infrastructure to be upgraded. As you can see, we have a D+ on our Americans report card in 2021 for the infrastructure, for the wastewater. That's not so good. So a lot of the drivers are the climate change, population shifts. You look at a city like Detroit, which had one of the largest treatment plants in the world for a long time, and then the people left. The industry was abandoned, and so they have a very difficult situation there. We have decreasing size in cities, but we also have places like San Francisco, which are very burdened by being the cities as the buildings go up. Their treatment plants, which already have a specific footprint, cannot grow anymore. So there's a lot of things that are driving resource-oriented sanitation, which is very exciting. And at Brightwater Tools, we are trying to develop these building scale treatment systems, which already do exist in the United States, but we want to include there are many places where building scale wastewater treatment is happening, but we want to include much more resource-oriented and nutrient recovery systems amongst that. So let's keep going, Miriam. That's Julia.
Yeah. So as Miriam was saying earlier, one of the big drivers in the US for nutrient recovery systems in particular is the problem of nutrient pollution. And with climate change and also increasing kind of population shifts and agricultural runoff, harmful algal blooms are increasing across the US, both in freshwater ecosystems and in coastal areas, as you can see on this map by the Environmental Working Group. And in particular, with the US Clean Water Act, states are required by the federal government to regulate nutrient pollution in their watersheds and achieve certain pollution reduction limits called total maximum daily loads. And this is a big driver for getting some nutrient recycling projects going. And at Rich Earth has been kind of one of our big funders over the years is through the watershed that we're in the Long Island Sound watershed. And so through that kind of collaborative effort to reduce nutrient pollution in that coastal area, they're interested in funding us for our urine diversion efforts so that we can help reduce the nutrient pollution that's getting sent downstream. And it can be especially what we've been kind of interested in is exploring urine diversion as a more affordable and simpler option in contrast to expensive kind of alternative septic system nutrient reduction technologies or installing sewer systems, for example. Or it can be a good kind of pairing with these higher tech systems. So another big driver in the US is the water conservation benefit. We've calculated that US wastes about 1.2 trillion gallons of clean water every year just to flush toilets alone. So it's kind of a way to visualize the scale that could be conserved if we started not flushing our small amount of waste in large amounts of clean water. There are many different kind of state and local requirements for water reuse that are rising. As Kim was mentioning, in San Francisco, this is particularly an issue. And so they have an on-site water reuse requirement for individual buildings that are at a certain scale to get water reuse going. So at Rich Earth, water conservation is definitely one of the motivators that makes urine donors decide to join our program. And at Brightwater Tools, their system will enable buildings who install the system to have reduced water bills via those avoided flushes, which has a potential economic benefit as well. Yeah, next slide. Yeah, go ahead, Kim.
So another driver for sure is the local fertilizer production. I love this picture with our tanks here because they're, that's about 5,700 liters per tank there, and those get filled several times a year. So that's my favorite part of the work that we do, is to see those fill and then empty and go out to farms, et cetera. Since we began this project, and got people interested and involved, the fertilizer demand continues to be much higher than what we can supply. So our farmers, specifically because of the region that we're in, we're surrounded by farms that have plenty of opportunity. We could certainly utilize all the urine that we could collect in our community if we were able to put that infrastructure together. We had some farmers who are starting to pay us. We actually have a scale, have created a price sheet, and this is just for pasteurized urine. It's not concentrated at this point. But people are beginning to really value it and come to us and say, we'd like to have it, we'll buy it from you. So as we said, Brightwater Tools the concentration will definitely facilitate a larger scale distribution. Can we go on? This project started very much at the community scale. As you can see, there's people pulling toilets in parades. There's people holding up, prizes because we give out a piss off award. We have people wearing T-shirts and coming to our grand opening of our depot. It's just, we really got this going because we created a real buzz in the community. People were surprised, but then once things got started, they were just really pleased to contribute. It makes people locally feel like something that people are always trying to figure out what we can do to make the world a more resilient place and to utilize less, but they realize if something just comes out of their body every day and they can contribute that to local soils and farms, it gives people a lot of good feeling about being able to do something. And as you can see on the right-hand side, there's a pair of good friends and colleagues from Cape Cod, and they are up in Vermont purchasing all the kinds of equipment that they need to get such a similar program off the ground in Cape Cod. So yes, there are challenges. Some of the other challenges that we have here are toilet availability. We cannot use the Lauf and Save and the Bostman. We can put them in individual homes, but they are not certified through the National Sanitation Foundation. It's very expensive to do that. So none of these companies want to do that until they know that there's a market. So it's just a really challenging situation. But our plumbing board in Vermont has allowed us one public installation of a separating toilet, the Bostman EcoFlush. But until we can get those more certified, for public installations, we will only be able to use waterless urinals to collect urine. The regulation is also complex, and this is how we approach it. You can see here a timeline since 2012. People looked at us and said, well, this is completely unique. We've never seen this before. What do we do? So early on, we were, we met with the leaders in our state, and because we're a small state, that made it easier, much easier than if we had started in a larger state like New York or Massachusetts. And we, I think you can just sort of read across here. We were basically regulated and permitted as a wastewater treatment facility. We had to go through the expense and all the activities of doing that. Now, after many years of having us test our urine product for heavy metals. They were very clear that you don't need to do that. It's only required on an annual basis. But what's really nice about regulation with us in Vermont is that we're working closely with our regulators. And as the issue of PFAS has become more critical all over the world, but very much so of interest in the United States, they have asked us that they've put a new requirement for us to test our urine for PFAS, which we have done recently. And we are happy to report that the results were that PFOS and PFOA and PFOAS, two of the ones that are now regulated through the EPA for drinking water, are non-detect in the urine that we have sampled so far. We're not going to put that out too wide because we'd like to do a lot more research to verify those first initial analyses. So that's a good thing. But what is really nice is that we work closely with our regulators, and they're enthusiastic, supportive, and they want to continue to engage with us in terms of, as we innovate and as we have a new product or we do a different treatment step, they want to stay connected to how we are evolving.
And
go ahead, Julia.
Yeah, I'll just talk about kind of the subject of contamination as one of the last challenges to cover today. And there are two main kind of areas of how we think about this, and those are pharmaceuticals and the PFAS. So with pharmaceuticals, especially as there have been a lot of kind of news reports about urine recycling kind of hitting the national news network, we've seen again and again a number one concern that people have, and this has also been a concern for people in our community, is about the pharmaceutical contamination potential for using urine as a fertilizer. And the other is with PFAS. It is definitely much more present in biosolids, as industrial waste and other kinds of manufacturing wastes are combined with human waste. And so there's been a lot of rising concern about soil contamination from biosolids that have been land applied. And Maine is actually the first state that banned the use of biosolids as a soil amendment due to some of these really striking soil contamination concerns that have forced farmers to close down their farms because the soil is so contaminated with the PFAS. So we're really committed to researching both of those subjects. So on the next slide, I have a little bit of a summary of a pharmaceutical study that we have done in partnership with the University of Michigan, University of Buffalo, and the Hampton Roads Sanitation District. And this study looked at the kind of environmental fate of pharmaceuticals in urine that was spiked with high levels of pharmaceuticals, so that it was detectable. And what they found is that really it doesn't seem to be uptaken in the crop at a significant level. So the way we communicate the smallness of the level that is in the crop is that you'd have to eat a pound of urine fertilized lettuce every day for 1,000 years to get the same amount of caffeine that's in a cup of coffee. And coffee, of course, is kind of the worst case scenario compared to the other contaminants because it's kind of the most common compound that's in urine. And then there were even smaller levels in the soil and even smaller levels in the parts per trillion range in the groundwater. So definitely comparable to, for example, folks that are irrigating with reclaimed wastewater water. And there have been studies on those that find similar results. So then on the next slide, Kim kind of mentioned that we've been doing these PFAS testings for our urine. So we also have a research project around PFAS and contaminants and biosolids that's funded by the Sustainable Agriculture and Research and Education Program of the USDA and also FFAR. And this project is exploring the production of biochar out of biosolids, which has been shown to reduce up to 99% of the PFAS in biosolids, which is a really exciting potential for reclaiming those valued resources for the soil in a way that's not contributing to soil contamination. And so we're looking at the benefit of removing the contaminants by producing the biochar, the potential for adding additional nutrients by combining biochar either with high-strength wastewater effluent sources or with source-separated urine to inoculate the biochar, and then using that to create a high-value fertilizer for crops. So we're actually in the first year of a multi-year study looking at applying these amendments and comparing them to some conventional and organic soil amendments and seeing the effect on the soil health and the crop yield and also nutrient leaching. And we're also conducting social research to explore farmer perceptions because we know this is a thing that a lot of farmers think about all the time, and this is a very novel amendment. So we're really curious to see if farmers would be interested in this kind of amendment and what their thoughts would be. And then just kind of a final slide to end sort of more on a note of hope is that really in the past couple of years, we've seen a huge surgence of interest in urine recycling and resource recovery, both from kind of the fertilizer production side, as fertilizer shortages around the world and fertilizer price hikes have made nitrogen fertilizer particularly challenging for farmers to access, and also the phosphorus fertilizer mining. And the kind of huge potential of this, resource that people could potentially reclaim. So Rich Earth has been seeing a lot more inquiries and a lot more interest in community replication since these news articles came out. So I think kind of one of the big drivers and one of the big stakeholders we work with is, the press themselves that help uplift these stories. Yeah.
Thanks. And Julia, do you want to talk about the Rich Earth Summit? Because I think these webinars are fantastic and giving a glimpse and a snapshot, but y'all actually organize an event for folks to come together virtually.
Yeah. So brief note, some of you may have been there in the past. We have an annual summit that is now virtual. This year is going to be more of a hybrid virtual and in-person summit. That's going to be November 7th through 9. And it's a sliding scale attendance, so it can be free to attend if you need that. And it's a space for urine reclamation researchers from around the world to come and share their pilot projects and their research that they're doing. So we have a new website for that, richearthsummit.org, where you can check out past recordings, and our registration will be posted there in a few weeks.